Corporate finance practice problem using Excel. Acquisition, expected value, standard deviation, and coefficient of variation calculations. Get ready. It's time to take our chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information on the left-hand side, we're going to populate that information into the blue area on the right-hand side, looking at an acquisition situation where one company is thinking of acquiring one of two other options and comparing and contrasting the results, focusing in on the coefficient of variation, which is typically the calculation that will calculate the risk involved. Now, note that in prior sections, we did a whole section on basically these kind of statistical type of calculations, included the expected value, the coefficient of variation, the standard deviation. So you can go back to that section if you want to focus in on those terms in more detail. Here, we'll be using those terms to kind of apply to like a merger type of situation. So we have then C company thinking about two mergers, being able to merger with two different companies. Company A is in its own industry, which is a volatile industry, while company B is in an industry which moves in the opposite direction, having negative correlation. So therefore, what we would expect then to happen is if the company mergers with a company similar to itself, they'll have increases when the economy is good for that particular industry, and they'll be able to maximize their gains during that time. But when the economy is not in a particularly good condition for that type of business, then they're going to have the declines, and the whole business will, be low during that time period you would expect. Whereas if they were to combine with a company that has skills sets that are a little bit different, it might not be as easy to get together with them, because that might not be an area that they're as proficient with themselves. But in a time of downturn, you've got that kind of diversification where you would think that the second company would then, or industry, would do better during that time. You got that diversification like you might have in a portfolio. So we got the information down below, and we're going to do our statistical type of calculation with these estimates we're coming up with. Remember that we'd have to kind of come up with these estimates in order to apply the statistical type of analysis. So we have the estimates of the estimated earnings for company A, which we're going to think are 60, 75, or 90. We're going to apply the probabilities, which you could think about in percents. Maybe we'll make them in a percent here, meaning 20% for the 60, 75, or 60% for the 75, and 20% for the 90. If we sum those up, that gives us our 100%. For company B, we're going to assume the 60, 75, and 90 on the estimated earnings, and then the percents assigned 10%, 80%, and the 10%, once again, the percents adding up to 100, giving us some framework to try to apply some statistical type of analysis to our estimates. So we're going to go up top and then apply this out. We're going to calculate first the the expected value, which is kind of like the average value when you think about your statistical analysis. So we're going to be picking up our same data over here, the 60, the 75, and the 90. I'm going to pick up the 60, put my cursor back on that item on the fill handle, drag it down. That gives us the 60, the 75, and the 90. The probabilities I'm going to be picking up at the 20, the 60, and the 20 equals the 20. Going to go ahead and highlight all of those. Let's go and make them number group, percentify them. Then I'm going to put my cursor back on the 20 on the fill handle and drag it on down. So we have the 20, 60, 20. Then we'll multiply this across. The 60 times the 20% likelihood is 12. We've got the 75 times the 60% not likelihood, 45. We've got the 90 times the 20% likelihood, or 18. Summing this up then will give us our expected value. Let's add some decimals to it. Selecting our column here, number group, add a couple decimals. So there we have it, and that's going to be our expected value. So the expected value, which is kind of like the mean or mid number, the average that we would be using when we think about our statistical analysis type of terms. So now let's go on over and say, all right, well then let's think about our variance, our standard deviation, and our coefficient of variation calculations. So we're going to pick up our possibilities again. which are going to be 60, 75, and the 90. And then I'm going to compare that to our expected value, which once again, it's kind of like the average when you're thinking about these kind of statistical analysis. That's going to be the 75 or the mean. It's probably a more statistical term. And then let's underline that font group and underline. There's the 75. I'm going to compare that all the way down. The 75. So then we're going to compare the possibilities to the expected value, which is 60 minus the 75. Then I'm going to copy that down, or let's just do it the whole way down. This will be 0. This will be 90 minus 75, or 15. And then what we do is we square that difference for our analysis. We're going to say, okay, this equals the 15 shift 6 for the caret 2. So we're going to square it. Obviously, this one's going to be 0. But we're going to say the 0 shift 6 caret to squaring it 2. And this one's going to be equal to the 15 shift 6 or caret 2. And there we have it. So that makes it a positive number, and it amplifies that difference. Then we're going to pick up our probabilities now, which is the 20, 60, 20. 20, 60, 20. Let's make these 3 cells percentized. Number group, percentize them. And then copy this 20 down using the autofill feature. There we have that. And then we're going to multiply this out. So we're going to be saying that we've got the 225 times 20% is going to give us the 45. We got the 0 times the 60% is 0. We've got the 225 times the 20% once again at the 45. Let's add a couple decimals to it. Number group, couple decimals. It's nice and even for us. That's nice. Font group and underline. That's going to be our variance, which sometimes they use the symbol squared, and you'll recall that it's going to be squared here, which is why we then often take that variance. I'll add a couple decimals to make it consistent, and then we remove the squared by taking the square root, and we call that the standard deviation. Let's do that this way. Standard deviation is going to then be equal to, and I think it's SQ square root is a function in Excel. So it's equals SQRT function to take the square root. You know, that's the thing, you know, with a little line over the top of it, square root, negating basically the squared component here. So square root of the 90. Let's add some decimals, number group, couple decimals there. So we're at the 9.4549. And then we're going to take the expected value to get to the coefficient of variation, the number we often use for our risk analysis. So comparing that to like the average, in essence, the mean expected value, and underline that, font group and underline. That's going to give us our coefficient of variation, which will then be equal to the 9.49 divided by the 75. Adding a couple decimals to that. You might see it in a percent format or simply adding decimals. So we're at the 0.12649. So we have an expected value. You can think about, you know, this being the middle point. If you're graphing it, we're expecting to be around that 75. Then we have the coefficient of variation, which is going to give us an idea of kind of the spread of that data, which doesn't make a lot of sense for us until we compare it to another set of data, as we'll do down here and B. And then it can tell us basically the risk variant that we're going to be involved here. So that's what we'll do here down on B now. So we'll do the same kind of thing. We're going to say this is going to be equal to the 60. We're going to calculate kind of like the average or the expected value. Pick up our probabilities, which is going to be the 10, the 80, and the 10. 10, 80, 10. Let's select these cells and percentize them by going to the number group percentize. Grabbing that 10 and then autofill it on down. So there's the 10, 80, 10. And then we'll take the 60 times the 10%. We'll take the 75 times the 80%. We'll take the 90 times the 10%. Noting, of course, that these percentages need to add up to 100%. This giving us a framework to think about the statistical type of analysis that we would like to apply to our decision-making process. Going to go up top, number group, add a couple decimals to it. It's nice and even, which is nice. This is once again going to be the expected value. Expected value is going to be the sum of the outer column, the 9, the 60, or the 6, the 60 and the 9. I'll add a couple decimals there just to be consistent. Let's underline under the 9, put an underline under the 9, font group, and underline. Now we'll do our same calculations for the variance, the standard deviation, the coefficient of variation is what we're kind of getting at here. That's the number that we can use for our comparisons. So we'll pick up the 60. And by the way, note that we're at the same expected value here. So that's the mean. That's kind of what we expect to happen between the two. So if you were to make a decision between the two, then that's not going to be the distinguishing factor. So if those become the same amount, then we want to think about, okay, well, what's the level of volatility? What's the level of risk that could be involved? And that could be the differentiating factor between the two. And we would expect the second one to be lower, given the description we had up top of it being in a negatively correlated area compared to the company C. So we're going to say 60, 75, and the 90. We're going to compare that to the average or the mean or the expected value, in other words. Picking up the 75, the 75, the 75, subtracting that out. The 60 minus the 75 is going to give us the 15 negative. 75 minus the 75 is 0. 90 minus the 75 is going to then be the 15 on the positive side. We're going to eliminate that negative number and amplify the results by squaring it now. We're going to take that 15, shift 6, which is the caret square root to 2 to square it. We'll do it here even though it will be 0. We're going to say equals that number, shift 6, caret, squaring it, and then equals that number, shift 6, squaring it with the caret, and 2. So there we have it. Now we're going to pick up our probabilities again, the 10, 80, 10, the 10, 80, 10. So there's the 10. Let's select these 3 cells. Let's add some percentization to it. Number group, percentizing them. Then I'm going to grab that 10. I'm going to autofill it on down. So we get the 10, 80, 10. Multiplying it across, we got the 225 times 10. Then we're going to take the 0 times the 80. And then we're going to take the 225 times the 10 once again. And let's add some decimals there. Just to add some decimals, we're going to go to the number group, couple decimals. Underline under the bottom number, font group, and underline. Let's go ahead and copy our same names down here. So this is going to be the variance. So I'm going to sum this up. Equals the SUM. Summing it up, adding a couple decimals. Number group, couple decimals on that one. Pick up the standard deviation because that has a squared component in it. So we're going to take the square root of it now, which is that little thing, with a line over it. But in Excel, we do it this way. Square root function. Square root function, 45 square rooted. Taking the root of that square. And then we're going to go to the font group and let's add some decimals to it. Okay, and then we're going to get the expected value. Expected value like the average or the mean in our statistical kind of thought process here, 75. And that'll give us our coefficient of variation. Font group underline first. Coefficient of variation then being equal to the standard deviation divided by the expected value. Adding some decimals to that number group, adding a couple decimals. How many did we add up top? 5. There we have it. So now, if we were to think about these two, we'd say, okay, well, the expected value is the same. That doesn't help me if I don't know which to do if the expected value is resulting the same. But this one comes up to a coefficient of variation at the 0.08911, less than the coefficient of variation up here, which if the expected values are the same, we would think we would want to pick this one because that would indicate that it would be less risky. If we were a risk-averse investor, you would think that we would pick the one with less risk. And again, the only reasons you'd want to pick more risk is in a situation if the risk was also resulting in higher value, generally meaning the expected value would be higher in that case. If the expected value is the same and the risk is lower, then usually you might be thinking then that you'd want to go with the less risky option.